let me, do you have any problems regarding the our class, previous class, before we proceed with nodal analysis this week or today? Okay. But before that, okay, before we proceed with the nodal analysis, I just want to clarify something regarding the analysis, okay, based on the basic Ohm's law. Okay, for example, you have a circuit like this. You have a multiple current source that is connected in parallel, okay, and you have a resistor here, and this is 3 ampere, for example. This one is 5 amp, and this one is 10 amps, and this one is 5 ohm. You can actually simplify this by sum up all the current source. So you have a single current source, which is 3 plus 5 plus 10, which is, this one is 18 amperes, okay, with a single resistor, 5 ohm. Okay, so I hope you understand this. Okay, but if you have, okay, so as you can see, this is parallel. Okay, so you can just sum up all the current source, because actually this one is actually can represent as an I total here. So this one is your I total. Okay, but if you have, for example, a circuit like this, but in between 5 amp and 10 amps you have a resistor. Okay, so this one 5 amp, 5 ohms. So you cannot sum 10 amp and 5 amp. Okay, you cannot sum them. So what you need to do is actually to, you can simplify this, but you can only combine 5 amp and 3 amps only. Okay, so this one becomes 8 amps, and you have 5 ohms here. Okay, 10 amperes and a resistor, 5 ohm. Okay, so this is the simplest circuit. Okay, this is the circuit that has been simplified. Okay, so you need to start your analysis based on this circuit. What happened when you have like this? For example, this one 3 amperes. This one is actually 5 amperes. Okay, the direction is reverse. Okay, so this is go up, this one is go down, and this one is also go down. 1 ampere, for example.
Doctor.
So, sorry?
No, nothing, doctor. Sorry.
Sorry?
Nothing, doctor. Sorry. By mistake.
I cannot hear you.
By mistake, doctor.
By mistake. Oh, okay, QR. Sorry. Okay, what do you mean? QR, is it QR? QR code? Who is asking? I cannot hear you. QR code, oh, okay, I forgot. So maybe we take a break 5 minutes after this, or 10 minutes. Then I will give you the QR code. Okay, so sorry for that. But I think we proceed first. Okay. Okay, so for this circuit, so what you need to do is actually you need to assume that the current go up is a positive, and current go down is negative. So you can simplify this. Okay, so 3 plus 5, 3 minus 5, okay, minus 1. Okay, so this one you should get 3 minus 5 minus 1 is essentially negative 3 amperes. Okay, So your values is negative 3 amperes, the direction is go up, or you can write down as a positive, but the direction is go down. Okay. You can either use this, but the value is negative. Okay. So this is the circuit after the simplification. Because this one is actually has been is actually inside the notes, but I don't elaborate yet. Okay, I don't elaborate what I call discuss these circuits. Okay, but you should know this. Okay. Okay, this is for the current source, and if you have a multiple voltage source that connected in series, for example like this, okay, so you need to total up. So for example, this is 5 volt, this is 10 volts. So what is the voltage here is actually just sum up. So your V total is actually 15 volt. Okay. If you have, for example, this one negative, like this, the polarity is like this. Okay. What you need to do is actually by using the KVL, okay. Negative 5, negative 10 plus V total equal to 0. So you will have your V total is equals to oh, this one, okay, sorry, this one is not negative 15. Okay, this one negative, this one positive. So you based on the KVL, okay, so negative 5 plus 10 plus V total is equal to 0. So your V total is positive 5 negative 10, which is negative 5 volt. Okay, and for this one V total is actually positive 15 volt. Okay, so that is how we simplify the circuit. So meaning that if you have this, so you can have a single source which is the value is negative 5 volt. Okay, or you can also write down as a polarity have been changed. So this one 5 volt here. This one is positive 15 volt. Or you can also write down as in negative. So you need to change the polarity. So this one will become negative volt. Okay. Okay. Clear? I hope this one is clear. Okay. So next is, for example, if you have this a resistor and then another one, this one 5 volts, this one 10 volts. Okay, so you can just use KVL also. So you will have negative 5 plus this one is maybe V1. So the polarity is like this. So V1 plus 10 is equals to V out. So 0. So this one you should get your V out is equals to 5, negative 10, negative V1. Okay, so this one your V out is actually negative 5. Sorry, this one 5. Okay, this one negative V1. So you can actually simplify your circuit like this. Okay, 5 volt. with a resistor. Okay, because if you draw back KVL, you should get -5. This one should be negative here. Okay, -5. Okay, sorry. Oh, never mind. This one -5. Okay, so need to double check this one. Okay. Okay, I think I need to double check this one. Okay, because this one I need to double check. But for your to clarify, so you just what I want to actually clarify is actually when you have a multiple DC source that connected in series, you just use the KVL and then calculate the total voltage. Okay, that is what I want to clarify in this class. Okay, before we proceed with the node analysis. Okay, I think we take a break 5 minutes because I want to generate the QR code. Okay. Okay, I have already shared with you the QR code for the attendance. Okay, so we proceed with the method of analysis. So in this circuit theory, we have two analysis of method of analysis, which is nodal analysis, and the second one is the mesh analysis. Okay, so this analysis is a method to simplify or to ease the analysis, the circuit analysis. Okay, rather than by using the basic Ohm's law, so we are using nodal analysis and also mesh analysis to help on the to solve the circuit. Okay, so we go first the nodal analysis. So what is the nodal analysis? The nodal analysis is interested in finding the node voltage. Okay, what is the node voltage? It's actually if you have a circuit like this. So this is node voltage. Okay, so this is actually node analysis. It is interesting to find what is the value of this node voltage. For example, V1. So what is the value of this V1? I have shared. Let me see. I hope I didn't share in the wrong group. Okay, I think I have shared it to the group. Oh, okay, QR code. Okay, or the slide. Okay, sorry. Okay, sorry. Because I think I'm sharing the PowerPoint right now. Okay, can you see? Okay, thank you very much. maybe you can just turn on your microphone, because sometimes I cannot read from the chat when I share. So it's not easy for me to check the chat room. Okay, so if you have anything, just turn on your microphone and just interrupt my presentation. Not a problem for me. Okay, so nodal analysis. So it is interested in finding the node voltage. So what is mean by node voltage? If you have like this circuit resistor, and then you have another branch, so this is what we call node voltage. Okay, for example, this one we define as a V1. So what is the value of the V1 here? Okay, so we have several cases that we will actually go through. Okay, I think, but this one is actually by theory looks complicated, but in reality is not too complicated. Okay, so let's look at case 1, the nodal analysis with independent current source. So as mentioned before, the objective of nodal analysis is to find the node voltage. For example, if you have been given a circuit like this, the question is actually to find what is your V1, which is the voltage across R1 and also voltage across R3 using nodal analysis. Okay, so the first step that you need to do is to select a node as a reference. Okay, this one is a very important step. Select a node as a reference node. Reference node meaning that the voltage is set to 0 voltage. And then assign voltage node as a V1, V2, and etc. Okay, so based on this circuit, usually we choose the reference node as a node that has a lot, that actually has what we call the biggest numbers of branches that connected to it. But sometimes it's not easy to determine where and which node. Okay, but usually for your syllabus, what we do is actually just select the most bottom node as your reference node. Okay, so for this circuit, so your bottom node here is set as a reference node, which is 0 voltage. Oh, I have a incoming call. Okay, I call you back. Sorry. Sorry for that. I think this is a scammer because the number is unknown, and when I try to call back them, engage. Usually, the scammer will have that kind of what we call uh, shape lah, dia punya bentuk macam tu. Because if you are from banks or some from bank apa selalunya, when we call back, it will go to the operators and so on. Okay, so we go back to our slide here. So your reference node is 0 voltage here, and then select another node, okay, as your variable voltage node. For example, this one you can see we have only 2 nodes available, this one and V2. So this is we define this one as a V1 and this node as a V2. Okay, so that is the first step. Select the reference node and then define the node voltage. Okay, because as you can see in this circuit, only 2 nodes are actually available. There are no other nodes here. Okay, this is not considered node. Okay, we are not considering this is node because it's actually the same 0 voltage here. Okay, this is not node. Also here, so this is not. is not a node. So V1 and V2 only is the two nodes that available inside the circuit. So we have V1 and V2. Okay. And then the second step is to apply the Kirchhoff currents law to each of the non-reference node. Use Ohm's law to express the branch current in terms of node voltage. Okay, so by using KCL for each node, okay, so you need to define the flow of the current. For example, this one is much better IA lah. IA, because you have I1 here. So IA. So the direction of the current source is like this, and the other current branch is not defined. As you can see in the original circuit here, you are not given the current direction. So you need to assume the current direction. Okay. So I think this one just IB. Okay, because we confused with I2 here. So you have a current source, so IA, so let it be just like this direction. Okay. And for current branch current here, so I assume that the current is going out from the node V1, and another current going out from node V1 also, and another current source which is the same direction as the current source. So this one is IB. So meaning that for this node we have two current going into the node IA. Sorry, only one current source, one current IA, and then there are three current branches that going out. One I1, I2, and IB. Okay. And the same case goes to V2 also. So for the KCL at node V2, this one is KCL at node V1. Okay. So KCL at node V2, you can see that you have two current that going into the node. So IB plus I2 is equals to I3. Okay. Oh, this one. Oh, this one also have already. It's okay. I think we just stick to this slide only. Okay. Because I have renamed this one I1 as IA, and the current source IA, and the second current source to IB. Okay. So there are three steps actually. The first one is actually what we have already done. We set the reference node, and then we define another node which is V1 and V2. The second step, and you need to apply the KCL for every non-reference node, which is we have already done. Okay. Okay. So at node V1 and also node V2. But for each node, this current equation, you need to write down in terms of voltage, in terms of the node voltage. So what is meant by in terms of node voltage?
Ohm's law.
Okay, let me take these pictures and then just transfer to my Microsoft whiteboard. I hope you can see Microsoft whiteboard right now. Okay, and I paste here. Okay, so because Microsoft whiteboard is much easier to draw rather than in the PowerPoint. So this one is your IB, this one is your IA. Okay, so not KCL and not V1. Okay, so we have one current going into the node IA is equals to I1, I2, and I3. Okay, So this is the KCL at node V1. Next is actually you need to rewrite this equation in terms of the node voltage. So right now, the current source is IA. So just let me be values of the current source. So I1. So this I1 you need to write down in terms of its voltage. Okay. We know that I1 is the current branch. So I1 is actually voltage drop. Voltage from, actually if you want, if you have like this. Okay. So this one is your V1 and this one is 0 and this one is your voltage drop R1. So the current that flow inside this is actually the current that flow, which is I1, is voltage drop over the value of the resistor, right? R1, right? You can also write down I1. We know that this voltage drop is actually a difference between this node and this node. So you can write down VR1 is actually V1 minus 0 volt, right? So you can write down, replace VR with V1 minus 0 over R1. So this is the what you mean by rewriting this current equation in terms of node voltage. So this is what it means. So right now we have I1 in terms of the node voltage will be V1 minus 0 over R1. Okay? Plus I2. So I2 is actually the current that flows from V1 to V2. The same case. Okay? So you have a node voltage which is V1 and this is your R2. So there is a voltage drop which is we define as a VR2. So this one is V2. Okay, and then this is the current I2. So your I2 is actually a voltage drop VR2 over the resistor. But we know that this voltage drop is actually the difference between V1 and V2. Okay, why V1 2? Because the current is flowing from V1 to V2. So V1 minus V2. Okay, over, sorry. So this is just a node voltage, okay? This is just a voltage. So we replace VR2 in terms of the node voltage. So VR2 become V1 minus V2 over R2. So we put here. So this one is I1 and I2 is V1 minus V2 over R2. Okay. Plus the current source, which is IB. Usually the current source is given. Okay, current source is a constant value. So the only variable is actually V1 and V2. Usually the other parameters R1, R2, the current source value is actually a constant value. Okay. So this is your first equation. Okay, from node V1. The second equation, okay, because you have two variables, right? V1 and V2. So you need another equation to solve this circuit. So same step, KCL at node V2. So you need to remain the current direction. Okay, if you have set the current direction like this, so please proceed. Okay, don't change the current direction. Okay. So for node V2 here, we can see that there are two current going into the node, IB and also I2. and only one current, which is I3. So you need to rewrite this equation in terms of it not voltage. So IB is actually a current source, so let it be just a values. I2 you need to change. Okay, so I2 is come from here, meaning that this one is actually V1 minus V2 over R2 equal to I3. I3 is actually the current flow from node V2 into a zero voltage. So I can just write down V2 minus 0 over R3. Okay. So you have right now, this is your second equation because you have V1 and V2. Okay. So V1 and V2, so you have two equation. Then you use simultaneous equation technique to get V1 and V2 equation. So node voltage, the main objective is to find the values of V1 and V2. Okay. After you got the value of the node voltage, then you can proceed with the question. For example, what is your V1 here? Voltage drop across R1, and what is the voltage drop across R3? You can also answer any questions. Okay, for example, what is the voltage drop across R2? What is current flow through R1? So it's actually from the node voltage. Okay, if you got the node voltage, then anything question you can actually answer by using the node voltage value. Okay, so we go back to this PowerPoint. Okay, so actually this one, the same one we discussed. So we just proceed. Okay. So actually, as you can see, this one is actually a two simultaneous equation where you can use usually for calculate for our exam, we just use calculator. Okay, you can have a lot another what we call methods. Okay, to solve this simultaneous equation by using either Cramer rules or use MATLAB programming. Okay. Okay, so this is the important note there. So to solve the node voltage, okay, because our objective is to get the value of the node voltage. To get the value of the node voltage, you need to start with the current branch, the KCL. Okay, that is the main key. Okay, so let's try this one. Okay, get the V1 and V2. Okay, this is the question. This is the circuit. So let's try, for example, using, this is my question. Using node analysis, okay, find Vx. So what is Vx? This is your Vx. And Ix, for example. Okay, so Vx and Ix. So the question is this, but you need to solve Ix and Vx by using nodal analysis. So how? So first step is actually to define which node are reference node. So usually we take the lowest, the bottom as our reference, and this one is your V1 and this one is your V2. Okay, then next is actually to define the current direction. So the current source is this direction, so we just maintain. And then for another current branch, so I assume that the current is going out. This one is also going out. This one, okay, maintain with the current source direction. And this one, I think, is also going out. Okay. So we first KCL at node V1. So KCL at node V1, you have a current source, 3 amperes, going into the node. And then you have two branch current. Okay. So we have this one. So V1 minus 0 over 2 ohms, right? And then another current from node V1 to node V2. So V1 minus V2 over 6 ohm. Okay. So this is your first equation. KCL next is actually for node 2. KCL at node V2. Okay, so one current go into, two current go out. So current into is actually V1 minus V2 over 6 ohm equals to V2 minus 0 over 7 ohm plus 12. So this is your second equation. Okay, but as you can see, these both equations are not simplified yet. So you need to simplify based using your basic mathematics. So this one, I think, should be 6. This one is 18. So this one should be multiplied by 3 through 3v1 plus v1 minus v2. Okay, so then so finally you will get this 4v1 minus v2 is equal to 18. So this one will be your first equation lah. Okay, first equation. Okay. Okay, next is actually not v2. So not v2. You need to simplify these equations. How? So this one is, I think, just write down V1 minus V2 over 6 ohm minus V2 over 7 ohm. I just write down V2, okay, because 0, so we can what I call ignore this. So minus V2 equals to 12. So this one just cross multiply. So this one is 7v1 minus 7v2 minus 6v2 equals to 12. So this one should be 7v1 minus 13v2 equal to 12. So this one
Doctor,
should be your...
it should be 12 times
Yeah,
42.
sorry. 12
42.
multiply with
42.
42. Oh, okay. 12 multiply with 42. 500, 504. Okay, 504. Okay, so this is your second equation. Then I think you can use your calculator. Okay, I haven't installed yet. This is actually a computer at my office. So I need to install first. Okay, so I think I just share. Okay, can you see my calculator? Just to show you where and how to use a simultaneous equation. So just go to mod. Okay, go to mod. This one big screen. Okay, mod, and then another, you click mod until you get to this menu, equation, math, and VCT. Just choose equation, which is equation is you need to click number 1. Okay, and then it asks about how many unknowns or variable. So since we have two variables and two equations, so just two unknowns. So you need to put the values, okay? So A1 is actually 4, is the first element here, 4. And then the B1 is actually the second element of the constant of V2, which is right now is -1. Okay, so -1. And then C1 is equals to 18. And for A2 is the element for the equation number 2, which is 7. And this one is this one is -13 and 504. So your X will be your V1, -6 volt, right? And to get the V2, just click equals, so it will give you the value of V2. So your V2 is -42. Okay. Oh, sorry, I think. Okay. So right now we have already calculated your V1 and V2. Okay, -6 volt and -42 volt. So this one is not finished yet. Okay, we haven't answered the question. We only right now finish calculate or finding the V1 and V2. So right now, after this, you need to go back to the questions. Find Vx. So the question is find Vx. So Vx, as you can see, is the voltage drop across 6 ohm, right? And this one also is actually a voltage difference between V1 and V2. Okay? V1 and V2. Maybe you want to ask me, why not V2 minus V1? Why? Okay? It's up to you, but for me, because the direction of the current is flowing from node 1 to node 2, so I'm assuming that the voltage V1 is bigger than V2. So that's why the current is flowing. It's flowing from node 1 to node 2. So you need to be consistent. Okay? So we just follow the direction of the current that we have already assumed. Okay? Since the direction of the current is going from node 1 to node 2, so meaning that you need to write down the polarity as V1 minus V2. So your V1 is -6, -42, which is you have -6 plus 42. This one should be 42 minus 6. 36 volts. Okay. Okay. Then Ix. Positive 36, meaning that the polarity that we have already given, assumed, is actually like this. Okay. Positive. And then Ix. So Ix is actually a Vx over the resistor values. So Vx is 36 volts. The resistor is 6. So meaning that your Ix is positive 6 amperes. Meaning that the current direction is actually based on our first assumption is correct, which is it will flow from node 1 to node 2.
Doctor,
Yeah.
I'm Huyin. I want
Yeah.
to ask about the node voltage. Is the negative 6 volt and negative 42 volt, what the meaning of that? Like, is there any different direction?
Okay, it's quite complicated to answer that because it depends on the circuit. Okay, I cannot answer on in general because it's actually when you go deeper to electronics and so on, then it depends on the application actually. So, but in this circuit theory, we just I think what you call just analyze the circuit, just analyze the circuit. Never mind on the polarity or what you call some what you call uh okay, let me try to explain. Okay, based on what we have learned. Okay, so V1 is -6, for example, this one. This one is -6 volts, and this one is -42 volts. It means that, for example, the current direction is like this. Okay, so this one is V2 ohm. V2 ohm is V1 minus 0 voltage, right? So V2 ohm is -6 minus 0, which is -6. So what is mean? Meaning that V2 ohm is -6 volts, meaning that the polarity should be this one. Meaning that if you, for example, if you have a multimeter, okay, a multimeter, you put your positive, which is the red cable, and then your common point is the black cable. Okay, using your multimeter. Okay, so this one is positive, this one is negative. Your multimeter reading will give you value of -6 volt values. Okay, but if you change, you got what I mean? Okay.
So it's like this, all this node analysis is only assumption from us, right?
Yes, we need to start with assumption.
Okay, okay.
For example, the current direction is not given the current direction. We just assume that the current is flow from node V1 to node V2. Okay, so the direction of the current is like this. If you got the direction of the current is positive, for example, after you have calculated, you got positive values, meaning that yes, the current direction is true, is going from V1 to V2. But if you calculate, you got this one is negative, meaning that the current direction is actually reverse. It's actually from V2 to V1. But as you can see, it is logic, okay? Because usually the current will flow from higher polarity to lower polarity. So right now, your higher polarity is V1, which is -6. V2 is actually much lower. So that logic, the current is flow from V1 to V2. Okay? For the polarity, it's like this. I can explain like this. If you, for example, you tap your multimeter at this resistor, okay, your multimeter will give you negative reading because actually, okay, because based on the circuit operation, it will give you -6 volt. Okay, meaning that the polarity is reversed. But it actually doesn't affect the operation of the circuit. Okay, just because of the circuit is operated like that, so you just actually follow what the circuit operated. Okay. Any other questions? Let's say, for example, okay, next Ix. So let's say to find this current, IY. So IY is the current that flow through 7 ohm. So right now you have the node voltage, right? So the current IY, you can simply just use V7 ohm, voltage drop 7 ohm over 7 ohm, or V2 minus 0, right? Over 7 ohm. So your V2 is negative 42. So negative 42 over 7 ohm. So you should get your answer is around 42, I think 6, right? Yes, 42, yeah, 6 amperes. Negative 6 amperes. Negative 6 amperes. So the direction of the current, okay, so you assume this, so but the value is negative 6 amperes. Okay, so this one, direction of the current is 12. This one 12 amperes. This one 6 amperes. So what is the current of this? What is the branch current? Ix. We have already calculated, right? Which is 6. Which is logic, right? 6 amperes. You have 6. You have 6 here. Okay. And then this one is negative 6, meaning that the current direction is actually not into this direction, but it's actually this direction. So you have 6 amperes. So 6 plus 6, you got 12. Right? So actually all actually balance. All the circuit must actually balance. The current that go into and out must be equals. So this actually need to match with the basic Ohm's law. So the nodal analysis and mesh analysis is actually to help our calculation in solving the circuit. Okay. 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 Anything? I hope it's clear. Tak dengar lah.
So far, okay.
Okay. Okay, so far clear. Okay. So next, I think I want to move a little bit. Okay. So we have already that is the basic one. Okay. I hope we have some good understanding lah on that. Okay. So next is we move to the much more complicated circuit. Okay. This one, the first cases is actually the voltage source connected one of the node and the ground lah. For example, if you have this node, so okay, so for example V1, so R1, so the current here is actually I1 is equal to V1 minus 0 over R1, right? And the third one, we have also looked at it because we have already discussed. If you have a tool, if you have, okay, sorry, this one. Oh, sorry, this one is not my mistake. Sorry, we haven't discussed this. Okay. Okay, this is a special case. Okay, we have 3 special case. So the first one, the voltage source connect one of the node and the ground. For example, if you have like this, so this one should be your V2, right? So, and then this is we set as our reference. So right now, this is the first case. The voltage source connect one of the node, which is this one, and then this is your voltage source between V1 and the ground node, which is 0 voltage. What happened? So what is your V1? So if you encounter this circuit, okay, where your voltage source is connected in between V1 and reference node, so you just put V1 is equals to your voltage source. So, okay, that is the first condition. If you meet or if you encounter this style of connection, so just put V1 is equal to your voltage source, because you know that voltage source is equals to the different voltage between V1 and 0 voltage, right? So that's why we put V1 as your node voltage is equal to voltage source. Okay. The second case, this one is quite, you need to carefully look at it. What happened when you have a voltage source that is connected with a series of resistors? For example, you have node here, and then you have a voltage source, and they connect with a resistor. This one is your V1, this one is your V2, this one is your R2, this one is your V source. So this is the second case. So how you want to deal with this type of connection? Okay. The first connection is very easy. You have V1 and then you have a voltage source, and then this is not zero. So your V1 is equal to voltage source. But right now you have a resistor here in series with the voltage source. So how you want to write the equation? Okay, so let's start with we know that V1, we need to assume the current first. So the current maybe we assume like this. Okay, we flow from V1 to V2. So V1 minus V2 must equals to Vs plus I R2. Okay, this is your current. So from here, you can write down your current is V1 minus V2 minus Vs over R. Okay, so this is how we write down the equation. Okay, you need to have a branch current. Okay, same case if you have, for example, the polarity is reversed, so it doesn't matter. For example, this one is negative, this one positive, so still you have V1 minus V2, but right now the current meet negative terminal first, so negative Vs. So right now your I will become V1 minus V2 plus Vs over resistor. Okay.
Doctor, this for if the current is in the opposite direction?
No. This is when you experience a circuit that has between a node you have a voltage source and a resistor. So how can you write down the current equation, the branch current equation? Okay, because for the node analysis, you need to find the equation for the branch current, right?
Right.
Okay, so how can you write the branch current if you encounter this between this node V1 and V2, you have a voltage source and a resistor. Okay, first what you need to do is to assume the current direction first. Okay, so in this example, I just assume that the current will flow from V1 to V2. So, and then the polarity is like this, for example, or for the voltage source, it can be negative or positive, it depends on the questions. Okay, and the current must enter the positive terminal of the resistor. The resistor must always have, the current must always enter positive terminal of the resistor. Okay, so I write my equation like this. V1 minus V2 is equal to negative Vs plus I R2. Okay.
Okay, doctor. Thank you.
Okay. I can also write down maybe this one, V1, same. This one negative, this one positive Vs. This one is your resistor, and this one is V2. So right now, I assume that my current will flow from V2 to V1. So the polarity of the resistor must be positive here, because current must entering positive terminal of resistor. So I write down my not voltage here. V2 minus V1 is equals to I R plus, because it Vs. Okay, and then I finally rewrite again the equation of the current of the branch current here is equals to V2 minus V1 minus Vs over R. Okay, so it's just assumption. After you need to start with assumption. Usually the current direction, you start with the assumption, then the final answer will determine whether your assumption is correct or not, because the assumption is actually just a positive and negative polarity only. It doesn't affect your what you call the operation of the circuit. It doesn't affect. Okay, you just analyze the circuit based on your assumption. So after my assumption, and then if finally I got my current is negative, or meaning that the current is actually flowing in the reverse direction. That's all. Okay. Okay, the last part is the most interesting. The voltage source lies between two non-reference node, which is we have this one, we have resistor. But right now, how can you deal when you have a voltage source between, for example, not V2 and V? What is the current, for example, because we want to get, right, to derive the branch current. But right now, the third case here, you have a voltage source that in between V1 and V2, and there will be a current flow actually. The current flow, we assume that the current flow from V1 and V2. So how can you derive the current equation? From this we can derive, right? So based on our assumption, the current direction is from V2 to V1. So we put like this, and equals to the voltage drop across the resistor plus Vs. Then you can get current. But right now, can you someone derive for me what is the current direction? What is the current equation when you have this type of connection? You don't have a resistor, you have only a voltage source. How can you derive the current equation here? Because to derive the current, you need to have a resistor at least, right? Because current is V over R. But right now, as you can see, we don't have resistor. How can you derive the equation? How can you calculate the current? Is it possible or not possible? Is it possible or not possible? Someone? Baranati. What is your answer? What is your opinion? Is it possible to derive equation? Because
Yes, it's
if
possible.
it's possible, because if you have resistor like this, V1 and V2, and then you have the current, right? So it's possible. This one I, V1 over V2 over R, right? But right now, you have a voltage source. Is it possible to write the equation for the current? Baranati, you said possible. Is it possible, Baranati? I ask you again. To get the current equation.
Doctor, we can
Yeah.
make Vs in terms of resistance. We can make it equal to I times R.
Cannot. Okay, right now, what is the value of the resistor? If you want to change, but usually for the voltage source, we cannot change because that is the energy source. You cannot change to a resistor because resistor we know is absorb the power, but right now, the voltage is actually supplying the energy into the circuit. You cannot model the voltage source with a resistor, right? Because if you model the voltage source as a resistor, meaning that it absorbs, it cannot generate. So we cannot represent or you model or you transform the voltage source into an equivalent resistor. Cannot. And you also don't know what is the resistor actually. It's not given. What is the resistor for this voltage source? It's not given.
So, doctor, so the conclusion,
Yeah.
we cannot derive the current, right?
Yes, we cannot.
So if we got the resistance, then that means we can calculate the current. If not, we cannot use, right?
Yes, if you have like this, like this question, this equation, this circuit, yes, you can derive the current. Okay, because at least you have a resistor, and this resistor is not belong to the source resistor. This resistor belong to the circuit. So you can if you have a resistor, yes, you can derive the equation of the current. But right now, you have only a voltage source only. You cannot actually. Okay, so the answer is you cannot. So how? For example, if you have like this circuit, okay, you have this node V1, this V2, this one is V3, and this one is 0 voltage. So you have 3 nodes. So next is actually you need to assume the current direction, okay, into every node. So I think this one like this one like this. Okay, so right now if you have a resistor, okay, for example, this one IX. So IX is very easy because you have a resistor. So V1 minus V2 over the resistor, right? And then what about this one? IY. So IY is V2 minus 0 over 6K. What about IZ here? So IZ is V3 minus 0 over 12K. What about this one? For example, IA. So IA is V1 minus V3 over 9K. So it's very easy if you have a resistor, right? To calculate the current or to get the equation of the current. But right now, for example, this one, I want to define this one, IB. So can you calculate for me IB? And this one, IC. How to derive? Can you get for me the current equation for IB and IC? Because at this branch, we only have a voltage source connected. It's not possible, right? It's not possible. Unless inside this you have a resistor. Then it's okay. But right now, inside this branch, you have only a voltage source. So it's not possible. Okay? So to solve this kind of, if you have, for example, the best example is this one. Okay? You have a voltage source that connected in between. So how to solve, how to get the current here, you cannot get the IC. Okay, I am reminding you that if you have this kind of connection, you cannot calculate, or you can calculate, but you cannot derive the equation of the IC. Okay, so to solve this analysis of this whole circuit that consisting a voltage source that connected in between two nodes, what we need to do is actually to represent this as what we call super node. Okay, so so I leave it the class today for using for this super node. So we will actually continue our class on next week. Okay, next week. Okay, next week on Sunday on super node. Okay. Okay, I think that's all. We will actually discuss the circuit with the this kind of circuit, this kind of connection. Okay.
Doctor.
Okay.
Doctor, can
Yeah.
you please share this, upload this slide in the e-learning or maybe to our WhatsApp group?
This yes. Actually, I have uploaded this in my YouTube channel. Why?
So this PowerPoint
Oh, this
slides.
PowerPoint.
Yeah.
I think I have already uploaded in the e-learning.
Doctor, nothing is there.
No, doctor.
Oh.
Not yet, doctor.
I think not
Okay.
yet, Doctor.
Yeah, doctor.
Okay.
Please.
I'm sorry for that. That's why if you have, you just let me know. Okay.
Okay.
Okay. I think for the for this one, I think I just upload in the WhatsApp group lah.
Okay, Doctor. Thank you, Doctor.
Okay. Thank you very much. Okay. Assalamualaikum.
Also the recording, doctor, please.
Yeah. Okay. Recording I will upload in the YouTube.
Okay. Thank
Okay.
you.
Okay. Bye. Assalamualaikum.
Alaikum salam.
Thank you, doctor.
Thank you, Doctor.